functions and their graphs. But before that, let us talk about what is the difference between a relation and function. So a relation is a relationship between the variables x and y such that for each value x, there may be one or more values of y. While a function is a relationship between an independent variable x and a dependent variable y such that for each one value of x, there is one corresponding value of y. So based on this definition, we can say that all functions are relations, but not all relations are functions. So to understand more about these two definitions, let us have an example. Okay, so these two sets of ordered pairs are example of relations. So the first set of ordered pairs, the first value of x is 1, then y is -2, then next is 3, y is 3, next is x is -2, y is 4, next is x equals 5, and y equals 7. Then the second set of ordered pairs, we have 2, -1, 3, 4, 5, 3, 1, 6, and 4, 1. So these are the two examples of relations in the form of a set of ordered pairs. Now, relation can be presented in this way. So we have this is the table. The first column are the values of x, and the second column are the values of y. And then we have the two ovals. The first oval are the values of x, and the second oval are the values of y. So these are examples of relations. Okay, when is a relation become a function? As I said a while ago, that all functions are relations, but not all relations are functions. When can we say that the given relation is a function? To answer the question, we need to know that function is a one-to-one correspondence. It means that for every unique value of x, there is exactly one value of y. Okay, before we go to the details of the example of one-to-one correspondence, let us know first some facts about the function or a function. So the x values are the domain or input, and the y values are called the range or the output. Now, the given example is an example of a one-to-one correspondence, and it is a function because function is a one-to-one correspondence. As you can see, for every values in x in our example has a corresponding exactly one value of y. So if we write this function in a set of ordered pairs, the set is 1, 4, -1, 2, 5, 8, 4, -1, -2, 1, 2, 5. In other words, one-to-one correspondence is there is no repetition of the values of x and no repetition of the values of y. Now let us move on to the second type of a function. Function is a many-to-one correspondence. It is a type of function where multiple inputs, the values of x, can produce the same output, which is the value of y. Let us take a look in our example of many-to-one correspondence. So this is an example of many-to-one correspondence. As you can see, that there are two inputs produce one output. The two inputs are 1 and 2, produce one output 4. Therefore, this is a function. If we write this function in a set of ordered pairs, the set is 0, 2, 1, 4, 2, 4, and 3, 9. In other words, a relation is a function if there is no repetition of the x values, even the y values are repeated. To summarize this lesson, a relationship between the set of input, the values of x, or the set of domain, and set of output, the values of y, or it is called set of range. Function, a relation which can be classified as one-to-one and many-to-one correspondence. So for one-to-one correspondence, for every input or values of x, there is exactly one value of y. Many-to-one correspondence, different values of x produce the same value of y. If you find hard to determine a function given a table or a set of ordered pairs, just remember this. The x values or the input must not be repeated. Otherwise, it is not a function. Okay, answer activity number 1 entitled Function or Not Puzzle. Direction: use the number outside the table only once to create 3 functions. You can pause this video for you to answer this activity. This is one of the solutions to activity 1 entitled Function or Not Puzzle, in which we need to use the numbers outside the table only once to create 3 functions. In creating or determining functions, always remember that there are 2 types of function, one-to-one correspondence and many-to-one correspondence. In short, there is no repetition of the input value. Let us now use the numbers outside the table to create functions. In the first table, the inputs are 2, -4, and 3. We choose the numbers from outside the table and put them in the x value or the input that are not 2, neither -4 nor 3. As we can see, there are 2 inputs or the value of x that we need to fill in and 1 output or the value of y. So we choose -1 and -2 for the x values and 4 for the y value. This is now a function since the input values are not repeated. 2, -4, 3, -1, and -2 are different from one another. And this type of function is many-to-one correspondence, in which multiple values of x or different values of x produce one or the same value of y. As you can see, 2 produces 4. Okay? -4 produces 4. -1 produces 4. Also, 3 produces 3 and -2 produces 3. Okay? So again, this is a function, a many-to-one correspondence. Now let us proceed with the next table. But before we proceed, let us mark x. Let us mark x with the number that we already use. -1, -2, and 4. Okay. In the next table, the x values are -1, 2, and 1. We need to use the 2 numbers to fill in the x values and 1 value for the y. So we choose 3 and 0 for the x value and -4 for the y value. Now, this table is an example of a function because the x values are not repeated, and this function is called one-to-one correspondence because for every values in x here correspond to one value of y. So this is one-to-one correspondence, and this is a function. For the next table, the table number 3, in table number 3, the x values are 4, 3, -2, and 4. What did you observe? Okay, I observed that there are two values of x that are the same. So we need to say x here are repeated. There are two 4s. So if that happens, this is not an example of a function. So we are done of this activity. Remember, we might have different answers, but as long as the input values are not repeated and you follow the directions, you are always correct. Here is our activity number 2, entitled What is the Code? You are inside of this zombie house, and you can only get out of this house if you know the code. The only way to find the code is to solve the problem given to you by the zombies. But you have only 5 minutes to do it. Will you be able to get out of this house? So this is the problem number 1. So solve this problem to get the first letter of the code. You can pause this video to solve the problem. Problem number 2. Which of the following set of ordered pairs is a function? Problem number 3. Which of the following figure is not a function? Problem number 4. Which of the following table of values is a function? Okay, let us answer activity number 2. So let us start with number 1. What number to be put in the x value so that the table become a function? Choose the letter of the correct answer. So we want this table to become a function. So in order for this table to become a function, x values here must not be repeated. Okay? So if we choose for letter A, which is 1, okay? If we put 1 here, there will be 2 1s. So if that happens, there will be a repetition of the values of x. So 1 is not the correct answer. How about when x value is equal to -1, letter B? So we put -1 here. There will be 2 -1s. Still, this is not an example of a function. So -1 is not the answer. Okay. How about if x equals -3? So if we put -3 here, now there will be 2 3s. Still, there is a repetition of the values of x. So -3 is not the answer. Now, if we choose 2 as our answer, still there will be 2 2s. So x equals 2 is not the answer in this problem. But if we choose 3, as our answer, there will be no repetition of the values of x. Each values of x here is unique. So 1 is different from -1, -3 is different from 3. So the correct answer is letter D. So the first letter of our code is letter D. Next, problem number 2. Which of the following set of ordered pairs is a function? So we have given 4 set of ordered pairs A, B, C, D. So again, if we want to determine if the given set of ordered pairs is a function or not, let us take a look on the values of x. The values of x must not be repeated. Okay, so take a look on the first letter A. We have the first values of x is 2, the second is -1, the third is 2, and the fourth is 1. So we can observe that there are 2 2's. So there is a repetition of values of x, which is 2. Okay, so this is not a function. This is not a function. For letter B, the x values are -3, -3, 4, and 2. As you observe, still there is a repetition of the values of x. We have 2 -3's, 2 -3's. So still this is not a function. For letter C, the values of x are 8, 5, 8, and 2. Still, this is not a function because there is 2 8 in the values of x. So this is not a function. For letter D, the values of x are 1, -1, 3, and -3. So there is no repetition of the values of x in letter D because 1 is different from -1, also 3 is different from -3. Therefore, the correct answer is letter D. D is an example of a function. So the second letter of our code is still letter D. Let us proceed to problem number 3. Which of the following figure is not a function? Okay, we are looking for a figure that is not a function. Okay, so we are looking for a figure that the inputs are repeated. So let us start with letter B. The inputs are 3, 1, -5, and 2. So there is no repetition of the inputs in letter B, so this is a function. How about for letter C? The inputs are 6, -5, -6, and 5. Still, there is no repetition of the inputs because 6 is different from -6, -5 is also different from 5. So letter C is a function. Letter D, the inputs are 1, 0, -3, and 2. Still, there is no repetition of the inputs in letter D. So letter D is a function. How about letter A? The inputs are -2, 3, -2, and 4. As we can see, there is a repetition of the inputs. We have 2 -2's. Okay, we have 2 -2's. Therefore, letter A is an example of not a function. So that is what we are looking for, not a function. So the answer for number 3 is letter A. So the third letter of our code is letter A. Problem number 4. Which of the following table of values is a function? Again and again, let us take a look on the x values if we are looking for a function or not a function. The x values must not be repeated to have a function. If it is repeated, then that is not a function. So let us start with letter A. The first values of x here is -1. The second is also -1. The third is 2. And the fourth is 3. So as we observe, there is a repetition of -1. There are 2 -1. So letter A is not a function. How about for letter C? So the x values are 2, 5, 2, and 7. Still, there is a repetition of the x values. We have two 2's right here. Okay, so this is not a function. How about letter D? The x values are negative 4, negative 1, 2, and negative 1. Still, there is a repetition of x values. We have two negative 1's. So letter D is also not a function. How about letter B? The x values are negative 2, 5, negative 1, and 0. As we observe, there is no repetition of the x values. So therefore, letter B is a function. That is what we are looking for, a function. The fourth letter of our code is letter B. So this is our code. If you get the correct code, then you can get out of the zombie house. Congratulations! Thank you for watching, and don't forget to click the subscribe button so that you will be updated for more videos in my channel.